Hello, this is the demo for IPO stocks analysis and prediction using machine learning and AI by Luke Sutton, N09133070. So straight away, if we look at the file structure of the project, this is the main file that the users will see. My project is an investigation, so the eventual implementation is just a concept at the end, a prototype that could be improved on in the future, but I will show it now. And I'll also show some of the investigation exploratory data analysis I've done. So basically they get this. The main data file will go in here, which we'll do now. So they come to this website, which is the official London Stock Exchange. They download this and it goes in the downloads folder. If I quickly grab it from my downloads folder and put it into main data, like this, it then comes in here. Okay, then they come to PyCharm. They go to LSE CSV to output CSV, which will convert the Excel file, and it will also do some magic rearranging the names of certain columns. So it's going to change some of the column names from initial trading open to just open, things like that. We're going to specify the days of data we want to add from Yahoo Finance, the library I used to get the Y Finance data here. So it uses the tickers from the data we just downloaded. So there's a column in the data we just downloaded if we have a look. It uses this column here to identify the company, and then it finds their financial data, because obviously there's no financial data in this. It's just, well, it is financial data, but it's not historical data. So if we run this, it's going to run, it's going to connect to Yahoo Finance, and it's going to go through all the tickers right here. So here it's going to output any errors or where it's fixing data, so that's just to bear in mind. While that happens, we can have a look at the code still. So at the end it's going to save it to a CSV, which we can then use in the other file to load the CSV, so we don't have to do this every single time. So the historical data we don't have to get over and over again. Pandas is obviously being used because data frames. We're also using datetime because we're converting between month day with dashes to diagonals. Right, so we're still going down the tickers. There is at this point about 3,000, I think, or no more than that, 6,100. That later gets cut down in the next program, because not all of these have tickers, so the ones that don't will get removed. So a certain amount of these get explored to be able to find out which ones are the most important to the final closing price of day 1, as well as day 7. The rest of the days were not implemented in the end, but day 1 and day 7 predictions are there. So this number here, this data was collected, but it could be improved on in the future. We're still waiting for this to finish downloading. It's currently been going for a couple of minutes. Hopefully it should be finished soon. While that finishes, we can move over to the main file. So the main file is where most of the code is. It's about 900 lines due to some code duplication, but basically it will get the data straight away from the output CSV from the other file, and then we do preparation, which is cleaning and analysis. So if we have a look here, preparation, then we get into analysis, then we'll go into predictions, which trains the models and saves them, and then user input loads them to test their own individual things later on. So if the user wants to, they can comment out these and then just use the models that have already been created, so they don't have to keep rerunning and training the models. Bear in mind this version does require GPU support for NVIDIA CUDA, so we've got lots of imports here. So obviously TensorFlow is the backbone of all the models. using the Keras as an interface to be able to use TensorFlow. Once this is finished downloading, I'll show you some of the graphs produced from Matplotlib and Seaborn. Here's configuring the GPU for TensorFlow. Obviously, after data analysis confirmed, we remove the unnecessary columns, we remove all the empty data, remove anomalous rows, cleaning the dates, cleaning basically every column because there's lots of errors and weird inconsistency. All of that is detailed in the report. Here we are changing sector, subsector, and industry for this column into one column because they will actually relate to each other, and correlation is pretty bad when you're looking at models. So if we look down here, this is finished now. So if we go to main data, you can see ticker data is being created. If we open that up, this is the new CSV that's been created. So these are all from Yahoo Finance, these columns here. So then this gets loaded. We close these. This will then get loaded by the main file. So if we run the main file here, let me clear this so it's a bit easier to see. So we run the main file. This is what the user is going to see, hopefully. There you go, so this is the user menu, so it's pretty simple. They just enter in issue price of the stock they're wanting, the market cap, say 20, issue 30, this one raise 30, issue trading opens 3, and then obviously if it's in the main market or it's in industrial, obviously these change the outcome depending on the model, that will predict the start. So here you can see end of day one value, the stock is more than £150, so its initial was 10, so obviously the variables that were entered were pretty favourable. The lowest price predicted was 141, the highest price was 999989 because it was the highest bin available out of the 5 bins that the models produce. Obviously was in the highest bin, so there is no upper bound to that classification. And then at the end of day 7, it expects it to be within the £0 to £50 range. So evidently it drops down after day 1. It's predicted a price change, a lowest price change of negative £10, and the highest of 40. This can keep going around and round and round, and then obviously an exit. I will also quickly show you some of the exploratory data analysis we were doing, and then I'll show you some of the models. So if you run this again, it should now show you the graphs that I've been looking at to decide my features. So I went through quite a few different graphs. So this was type of issues placed on CLSE. So here we've got, if we have a look, you can manipulate these graphs. So these all went into the report. Okay, so these were the type of issues. So obviously we're only interested in new company placings really. These will be the IPOs. These get cut later on. The next graph was, let's have a look. Oh yeah, it was countries, so I separated the country column into United Kingdom, not United Kingdom, because there were so many species beforehand. Another one, there was a lot of industry sectors, so I combined them in together as I described earlier. The IPO quantity per sector was similar. We've got the number of IPOs released per year, depending on their industry. So obviously there's a bit of a correlation there, but I think that's because the codes changed at 2018, so there's going to be more with the newer codes up here and more with the older codes up here, so obviously they changed. Here we've got another graph released in the report. It shows the IPOs released per sector over the last 20 years, so obviously you can have a look. 2018 there's a spike, you can configure the graph around. So if we bring this in, we can have a look. Purple, 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 mining, there's a spiking mining IPOs in 2018. But there was no really correlation with time according to the heat map that will be produced in a minute. obviously there's a lot of, this is why I combine subsectors and sectors, there's so many. Um, you've got issue price versus um, adjusted close day one. We've got a bar chart here. This is the mean here, minus 0.3. Histogram of money raised. This is the mean and the median on this plotted on this. So all of these graphs decided which features I kept in the end for the models. I'm just going to quickly skip through some of these. So we've got density graphs. Okay, here's a heat map. This was pretty useful. So this showed the correlation between the variables, so we could try and reduce the correlation because we had some variables that were affecting or that relied on each other. So it meant that when you changed one of them, the other one also changed, which meant that the model was quite unstable. So obviously here, day is negatively correlated to industry consumer discretionary. This is all the correlations. There is more if you expand the heat map out. Fisher score. Evidently, the opening price was the most important thing, according to Fisher. There you go, initial trading open. These don't even register. Histogram of target variable. Close that. Right, that's all the exploratory data analysis done. If we go to the models, so this is training the models. So obviously I compared the accuracy and the all the other variables. So these are the columns I kept for each one of the models. As you can see here, logistic regression. They're all here. So we got MLP. So we got the base model, then we got the hyperparameter testing, then we got the tuned model. So I could quite easily just run all of these real quick. So we put breakpoints in and we run it again. I can show you MLP running hopefully. And we've got to skip through all of these graphs real quick because I forgot to close them. Close all of this. There's quite a few. Nearly there. Right. Hopefully. When it loads. Basically, if we get to MLP, I don't know why it's not loading. You see here we split them into bins. There's 5 bins per model. Negative to 0, 0 to 50, 50 to 100, 100 to 150, 150 plus. Instead of doing regression, I did classification due to the low accuracy problems with regression. Predicting a stock price with regression is pretty insanely hard. So instead I decided to change it to classification. In hindsight, probably should have made the bins smaller. They're quite large for the dataset, so I wish I'd done maybe 10 bins or maybe just change the values to better accurately represent the data. Obviously we split it into train and test. This happens for all the models. And then we scale them so that everything's got the same importance compared to the model. Or going into the model, sorry. We can get the mean, we can get the variance. Then obviously for MLP, you've got the curator interface, you've got the layers, so fully connected dense layers here, moving down and then back up at the end. From logic is true, that means it's the same as softmax at the end. Obviously all of these can change. These hyperparameters get changed by the hyperparameters in this one. Confusion matrix can be printed. Classification report can be printed. This is all the tuning here with hyperband using Keras tuner library. That was quite important. Basically this happens for every single model. Yeah, so we've got every single base model there. Random forest, logistic regression. Logistic regression proved the best. We got day 1 and we got day 7. Day 7 uses the output of day 1, which means it builds off it, so it can try and predict a bit better. Obviously, we got k-fold training going on, so it uses multiple of the same model and then combines them all together, much like a random forest is lots of decision trees put together. And then we can save them using joblib, which again puts them into this file here. These are the models here, day 1 and day 7, and these get loaded and then tested against with the user. So if here we go, we're on day 7 here. So we load the model and then we look at all the columns and we predict what the price is going to be. That is a brief overview of my project for my final year at NTU. If you have any questions, feel free to send me a message. Thank you, Luke Sutton.